In this video, we want to learn about something called the inverse trigonometry functions. And you may remember from prior sections in algebra that inverse is basically another way of saying opposite. So real simple example, if I told you that I had the point 2 comma 3 on a function, the inverse of that point would be switch the x and the y. Invert something means switch. So the inverse point would be 3 comma 2. So when it comes to trig functions, when we're talking about inverses, whatever y equals on the sine function becomes the x value on the inverse of that sine function. So real simple example, if this is my function, if I have y equals sine of x, hopefully we know that sine of 30 degrees equals 1/2. So that means the point 30 degrees comma 1/2, or if we were doing it in radians, it would be pi over 6 comma 1/2. Pi over 6 is on the graph of sine. Pi over 6 comma 1/2 is on the graph of sine. That means on the graph of inverse sine, we would have the point 1/2 comma pi over 6. We're basically switching these around. And I'll show you a picture of this. Okay, basically the domain of sine, domain refers to the x values. The domain of sine is the same as the range of inverse sine. The range of sine is the domain of inverse sine. So let's just move down. Right. So here's the domain. Here's the graph right here of sine of x, or sine of theta. We'll use x because we're using y. So let's take a point here. We have the point right here. Looks like we have the point at x equals pi over 2, or 90 degrees, and y is 1. So ask yourself this question: if the point pi over 2 comma 1 is on the graph of sine, then what should be on the graph of inverse sine? Okay, and hopefully you said 1 comma pi over 2, so let's make our way up here to the graph of inverse sine. 1 comma pi over 2, and sure enough that is on the graph. Okay, one thing you'll notice about this graph is its domain and range is restricted. You can also see this in a calculator. Okay, if you go to if you talk about the domain refers to the x values. Remember the range on sine, let's go down a sec, the range on sine, this graph right here, it goes from a low point of -1 to a high point of 1. So the range right here is basically y is greater than or equal to -1 but less than or equal to 1. Okay, the domain right here is all real numbers, but even though the domain is all real numbers, if you look at a unit circle, sine is the y coordinate. The y coordinate basically has a lowest point of -1 right there, goes to 0, and then it goes to +1. So sine actually goes through its complete range of values in this red region right here. It goes through its complete range of values between 90 degrees up here, and then down here this is either 270, but since we're going in this direction, we're going the clockwise direction, we could call that -90 since we're traveling this way. So the sine goes through its full range of values between 90 and -90, and it has a range of -1 to 1. So keep that in mind as we look at this graph. So this says the range, okay, the domain of this function should be the range of the other one. So we said the range of the other goes from -1 to 1. Well, if you look at this right here, this is a point of -1, and this is a point of +1. So the domain right here is x is between -1 and 1. The domain of this function was the range of this function down here that we just looked at. The range, we said that it goes through this right here, that unit circle picture, goes through its complete range between -90 and 90. If you look at that, those green points and that red line I drew right there. Okay, that 90 and -90, another way of saying that is pi over 2 and -pi over 2. So if you look at this graph, the range right here goes from -pi over 2, and that's less than or equal to pi over 2. Okay, that's equal to, here's pi over 2 up here. So it goes through its complete cycle in that. So the domain of inverse sine is -1 to 1. The range of inverse sine is -pi over 2 to pi over 2. So I want to show you what that looks like on the calculator. So where do you find inverse sine? You go to, let's say, the sine of 90 degrees. Oops. Let me just clear that for a second. Actually, let's also make sure that we're in degree mode, which is what we always have to do. Alright, so we are in degree mode. So you can see the sine of 90 degrees. We know this from the unit circle. The sine of 90 degrees equals 1. So let's hit second sine. and we'll do the inverse sine of 1, and we should get 90 degrees, and sure enough we do. There's the connection between them. Actually, let me move the screen so you can see that better, because I think it's getting cut off right there. So this inverse sine of 1 is 90 degrees, okay? All of the answers that the calculator will give you when you plug in inverse sine will be between 90 and negative 90. So just to prove that to you, let's do the inverse sine of negative 1. Okay, so the inverse sine of negative 1, like we said, the domain of this function should be between 90 and negative 90, and you can see, as soon as I move the window there, you can see that it equals negative 90. It's not going to give us 270 because we said right here that the domain, or sorry, the range is between negative pi over 2 and pi over 2. So let's take a look at the cosine ones. It's the same idea. Okay, the cosine function is right here. This is what we've seen before. So the domain and the range of this function, the domain is all reals, but let's think about what does cosine need to go through. So cosine has a biggest value. It's the x value, has a biggest value of x equals 1. Right here x equals 0, and right here x equals negative 1 on the unit circle. So it goes through its whole range of values. Darker color so we can see that this orange line right here goes through its whole range of values in this orange zone right here, between 0 degrees and 180, or between 0 radians and pi radians. So that means the domain, the range right here goes from a peak of 1 to a bottom of negative 1, so that's the same as sine. Okay, and the domain is all reals, but we'll put a parentheses here, it covers everything it needs to cover between 0 and 180, because it goes from a complete range of 1 to negative 1. So keep that in mind as we look at the graph of inverse cosine. You can see right here, first of all, the domain, just like sine, the domain goes from over here from negative 1, and then it's less than or equal to x, which is less than or equal to 1. Okay, and then why is it going from up here? It's going from pi, and then it's down here, it's going to well, it got cut off a little bit, but it should be going to 0. Actually, let me move. I'm going to move this sine graph away so you can see it. So it's down here, right here. It goes from 0 to pi. So the range right here, 0 is less than or equal to y, which is less than or equal to pi, or 180 degrees. Why is that? Well, we just said, if you look at this graph right here, cosine goes through its total values between 0 and 180. So that's why it has the range. Inverse cosine has the range that it does. Last graph would be tangent. Okay, so that's the graph of inverse tangent. Let's kind of get a sense of why that is looking at this graph. This is the graph of tangent. Okay, so tangent of x. So again, the domain right here is tangent, or x cannot equal any multiple of pi, or 180. You can see we have asymptotes right there. So it does not equal 180 degrees times n, or it does not equal multiples of pi times n. Okay, the range is all reals, but once again, let's look at the unit circle so we can see when does tangent go through its complete cycle. And tangent is the slope. So the slope is undefined right here because tangent is sine over cosine. And sine is the y coordinate on the unit circle. Cosine is the x. So y over x is another name for slope. So it's undefined here and here. And then in between these, you can see the slope. If we were kind of tracking this slope right here, these blue lines, okay, right here the tangent is equal to 0. Or the slope is 0 at that flat line, and then it starts to get negative, 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 and then down here again it's undefined. So it looks like it goes through the same cycle as cosine. Between negative 90 to positive 90, it covers every value it needs to cover. So if we look at inverse tan, the domain on this one is x does not equal multiples of 180 or multiples of pi. Okay, right here we look at the domain and range. The domain is all reals. Okay, the domain is all reals, but really we cover everything we need to cover. Like we said down here, we cover everything we need to cover between negative 90 and 90. So that's why here's 90 degrees, pi over 2. Here's negative 90. You can see these kind of level off. They become asymptotes. If you were to take this graph and kind of turn your screen sideways, it would look like the graph of tangent basically, because it's the inverse graph. Okay, the domain of this function x can be pretty much anything, but the range goes from pi over 2 to negative pi over 2. Okay, that's where the y's go, and that's because tangent goes through its whole cycle in that zone. What that means is if you do the inverse tan in a calculator, it's always going to return you a value between negative 90 and 90. So just to prove that, let's do the inverse tan of, and we'll do the inverse tan. We don't want to do negative 90 because we said it's undefined. Let's do negative 89. And this should be a pretty large negative number. Okay, so inverse tan of negative 89 degrees, and you can see kind of a steep slope. Let's try inverse tan of negative 90 since we said that was supposed to be undefined. So negative 90 degrees, let's see what happens there. And whoops, I think we might be, I slip out of degree mode. Nope. Let's see. I'm sorry. I'm doing tangent of 90. Tangent of 90 would be undefined, and then we want to do. We'll do this instead. So tangent of 90, you can see that's an error. We get an error there. If we do inverse tan of some huge number, so let's do that. We'll do inverse tan of some enormous positive number, so like 1,000,000. This should be really close to 90 degrees because the slope is so steep, and you can see 89.99, so really close to 90. So that's just a sense of what the graphs of those functions look like. In the next video, I'm going to show you how to actually find the values algebraically.